Hi, and welcome to EJC Online Classroom. My name is Michael Wilson, and I'm going to be teaching you some mathematics today. So clear your minds and get ready. But before we get into it, let us pray. Father, we come before you acknowledging that you are the great teacher. You are all-knowing and all-wise, and it's only through you that we can gain your wisdom once we stay connected to you. As we're about to go through some mathematics today, we ask that you energize our minds simultaneously. Bless us. And as at the end of this lesson, all can say that it was well and we have learned. Bless us, we ask. And thanks again. In Jesus' name I pray. Amen. Now today we're going to be looking at simultaneous equation. Now, simultaneous equation. Before we go directly into simultaneous equation, let us just look at what simultaneous equation is. Conceptually, which is the way I like to teach, to break things down in concept. Now, the word simultaneous means occurring or happening at the same time. Occurring or happening at the same time. Does this mean that simultaneous equations are just simply solving equations at the same time? Is that even possible? You could try. Here's a list of equations, some algebraic equations for you to solve. I dare you, solve these all at the same time. Quite impossible, isn't it? You have to solve them one by one. So simultaneous equation is not solving equations at the same time. That is realistically impossible. So, what is simultaneous equation? Simultaneous equations are really two or more equations that have the same solution. So when we define the word simultaneous, we look at events happening at the same time. But in the case of equations, it's really having the same solution. So simultaneous generally is simply expressed in terms of time. However, when we talk about the equations, we express those in terms of the solutions. And of course, we know that solutions to equations are basically values of the unknown that satisfy the equation. Now here are two examples of simultaneous equation. The first, we see two equations basically representing two different events. However, they are equations in terms of x and y. Now because they have the same solution, it means that the value of x for the first equation must be the same value for x in the second equation, and it goes the same way for y. In the other set of equations, we realize that there are three variables, a, b, and c, all adding up or summing up in some way to give a different value. However, the value of a in one equation must be the same value in all the other equations, so much that they will give the same value at the end. So each variable in each equation has a single value that satisfies all the equation. Now we can see for x in the first set of equations, x is equal to 2 and y was equal to 1, and we can check it. 2 plus 1, 3. 2 minus 1, 1. And even the other sets of equations on the other side, we see that a is 1, b is equal to 2, and 3. And c is equal to 3. So all the solutions, the solution to the simultaneous equation must be the same right through. Now I want us to take note that for the first set of equations, there are two variables and there are also two equations. So if we have two variables to solve, then we have to use 2 equations. If we notice the other set of equations, there are 3 variables, A, B, and C. And so we need 3 equations. There is no way we could solve for 2 variables using 1 equation. So hence, we have to solve them simultaneously. And by simultaneously, we mean to find that one single value for that one single variable that satisfies all the equation. Now, how do we solve simultaneous equations? So we want to get now into the methods of solution of simultaneous equations. And there are quite a few methods of solutions, some of which are elimination, substitution, method of plotting a graph, we call it the graphical method, and also the matrix method. Now we won't be looking at all of those today. We're just going to focus on the first 2, and those are methods of elimination and substitution. So let's just get right into it. Now the method of elimination. Now this method simply involves eliminating one variable so that we can focus on the other variable. After all, that is what elimination means. We have to get rid of, right? Elimination simply means to get rid of. So when we eliminate the garbage off the floor, we get rid of the garbage off the floor. So in a case where we're dealing with a simultaneous equation having 2 variables, as a matter of fact, we're not going to be looking at the 3 variables. We're going to be focusing on simultaneous equations that have 2 variables and hence 2 equations. So how do we eliminate? Do we just take the value or take the variable out and throw it away, and then we are left with an equation with just one variable? Focus on that. No, it has to be systematic. So there's a way that we go about eliminating without interfering with the entire meaning of the equations. So elimination is done by simply adding one equation to the other, or subtracting one equation from the other equation. You might ask, how does adding an equation to another equation or subtracting an equation from the other equation suffice for elimination? Well, we have to first examine the equations to see what is the best thing to do. However, there are certain things that must be met. There are certain conditions that must be met before we decide whether we're going to add the equations or we're going to subtract the equation. Now, these are the conditions. So how do we decide? If both equations have what we call additive inverses, then we go ahead and add the equations. So let me repeat that. If both equations have additive inverses, we go straight ahead and add the equations. Now, the presence of additive inverses already suffice for elimination. Now, the word inverse should give us the impression that when we add those, then some elimination is going to take place. I'm going to explain that a little bit further. Now, what's the other condition for deciding what to do with the equations? Now, we also need to look to see if both equations have like terms. If they have like terms, then we want to subtract one equation from the other. Now, I did say I'm going to explain a little on what additive inverses are. Now, additive inverses are basically numbers, 2 numbers, really, that add to give 0. Hence, additive inverse. So we're looking at a number that must be added to another number to give 0. For example, the number 3. The additive inverse for 3 is negative 3. Makes sense, because if we add 3 to negative 3, 3 plus negative 3 will give us, I can hear my bright Kingsway students shouting the correct answer, of course, 0. Negative 6. The additive inverse for negative 6 has to be 6. So it's a matter of whether, if the number is negative, then the additive inverse is going to be positive. So that when you add the two together, you will get 0. So the additive inverse for x is negative x. Of course, clearly, if we add x to negative x, we must get 0. So what are additive inverses? Two numbers that add to give 0. And essentially, those are basically numbers of the same magnitude, but one is positive and the other is negative. So this is what we're looking for in the equations. So if we see a number in the first equation that has another number in the second equation, which is its additive inverse, then we can go ahead and add those equations. First example. Now, this system of equations should be familiar to us. I started the introduction of this topic with this set of equations. X plus y equal 3, x minus y equal 1. And of course, we already showed that x was equal to 2 and y was equal to 1. So we have to prove now that this method of elimination works. So we want to get x to be equal to 2 and y to be equal to 1. Now, let's examine the equations. Remember, we're doing the method of elimination, and so we're looking to see if, 1, both equations have additive inverses, or 2, both equations have like terms. Now, just look at it for a while and see if you can identify if they have additive inverses or like terms. If you say they have additive inverses, you are correct. Those additive inverses are positive y in equation 1 and negative y in equation 2. I want to pause here to point out to you that these equations have to be labeled, and so I slipped in my numbers just to label the equation. So I have a circled 1 up top to identify the first equation as equation 1, and a circled number 2 next to equation 2, of course, to identify it as equation 2. And so we continue to use these circled numbers. So whenever you see a circled number, we're referring to a particular equation. So if I have a circle 3, then I'm referring to an equation 3. And we'll get to that so you can understand what I'm talking about. Now, for those who were examining the equations and you identified like terms, you're also correct. There are like terms in this equation, and those are x. Of course, we have an x in equation 1, and we also have an x in equation 2. So those are like terms. However, if they are like terms, we have to subtract. If they are additive inverses, we add. Now I can tell you, I can speak for the fraternity of mathematicians that we always prefer to add. And even students can tell you, it is always easier to add than to subtract. So I am going to go ahead and add those equations because of the presence of the additive inverses. So we're going to add. So I pretty much take those circle numbers to say circle 1 plus circle 2. That simply means equation 1 plus equation 2. All right, so we're basically writing our subtitles in terms of symbols. Of course, remembering that this is how we're going to identify the equations. So equation 1 plus equation 2. That's what we're doing. We're adding the equations. Now, notice I put some brackets there because when we add the equations, we're going to end up with a single equation, hopefully, with one of these variables being eliminated. Of course, since the additive inverses were positive y and negative y, then the variable y is the one that we're attempting to eliminate. So how do we add these equations? Now we simply add the terms, the like terms in each equation. So let's go. We're going to add x from equation 1 to x in equation 2. Then we're going to take y, positive y from equation 1, and we're going to add that to negative y from equation 2. And of course, don't forget your constants. We must add those as well So all the elements of the equations are added, showing equation 1 plus equation 2. Let's go again. So equation 1 plus equation 2 will give us x from equation 1 plus x from equation 2 plus positive y from equation 1 plus negative y from equation 2. And of course, that will equal to the 3 from equation 1 plus 1 from equation 2. So we can go ahead and simplify that equation. I hope you have your notebooks out and you are writing as we move along. Now, when we simplify this equation, we add all the like terms. X plus x gives us 2x. Now, y plus negative y will give us 0. Of course, they are additive inverses. When we add them, we get 0. So we have a 0 there. And of course, 3 plus 1 is equal to 4. We don't need our elementary teacher to tell us that. So simplifying it, of course, we don't need the 0 there. It's taking up space. So 2x plus 2x equals 4. And that is the equation that we derive from simply eliminating the y variable. So now we have an equation in one term. One variable, one equation, we can go ahead and solve. So let's solve for x. If 2x is equal to 4, then, of course, we're multiplying by 2x on the left-hand side. So we go over to the right-hand side and divide by 2. So that gives us x equals 4 over 2, 4 divided by 2. And voila, x is equal to 2. Now you might have thought earlier that because we're solving simultaneously, and of course the word simultaneously generally giving the meaning of happening at the same time, that we probably would be solving the two variables or solving for the two variables at the same time. But no, I want us to take note here that we have to find the value of one variable first before we can solve for the other variable. So now that we know the value of x, we can simply solve for y. And how do we do that? We simply substitute the value of x into any of the other equation, but I'm going to choose equation 1 because equation 1 is all positive. I am running away from those negatives. And believe me, students, you're not the only ones who do not like negative numbers. I can speak for the fraternity, for the mathematicians in the world. We don't like negatives either. We try as best as possible to get rid of them, if we can. And so, we're going to just go with equation 1. Let's go right ahead. So equation 1 is x plus y equal 3, right? And of course, we solved x to be equal to 2. So wherever x is, we're going to substitute that for the value 2. So we have 2 plus y equals 3. Now that we now have another equation with one variable, we can go ahead and solve for y. Since we're adding 2 to y on the left-hand side, we do the opposite on the right-hand side. Of course, by virtue of transposition, y is now equal to 3 minus 2. And we don't need our elementary teacher or our calculator to determine that 3 minus 2 is equal to 1. So now we have our general solution of the system of simultaneous equations. X is equal to 2. Y is equal to 1. But this is the system of equation that we used in the beginning, in the introduction. And if I remember very well, x is equal to 2 and y is equal to 1. Now to jog your memory, that's the system of equation that we started with. And of course, substituting for the values, we can show that when x is equal to 2 and y is equal to 1, the system of the equation is satisfied. And by satisfied, we mean that the values add to give the constant values on the right-hand side. Let me repeat that. So the values for the variables, they add to give the constant on the right. 2 plus 1 for the first equation gives us 3. 2 minus 1 for the second equation gives us 1. Let's try another example. Now remember, Always label your equations because you don't want to be confused. Very, very important. All right, so when I write my simultaneous equations, I always have my circled numbers next to it. The first equation, of course, having the label equation 1. And equation 1 is simply the numeral 1 in circle. We call it a circumscribed number. In the field of mathematics, we use that term, circumscribed. And the second equation, of course, we call it equation 2, so we have a circumscribed numeral 2 next to it. All right, so analyze this equation. Remember, we are using the method of elimination. And so we want to decide if we're going to have to add the two equations or we're going to have to subtract one equation from the other. Can you decide what do we do? Remember, in order for the equations to be added, we must identify additive inverses. Do we see any additive inverses? I don't see any. Remember, additive inverses are numbers that add to give 0. One must be negative and the other is positive. And the way I see it, this set of equations does not have any negative values, and so we cannot add the equation. So, of course, we identify that there are like terms in this system of equations, and those like terms are x in equation 1 and x in equation 2. So, we're going to decide to subtract one equation from the other. Now, when we're subtracting, we have to be careful how we go about subtracting. Remember, we don't like negative. So if we want to avoid having to deal with negative values, I mean, if we can't help it, then we have to. But if we can avoid it, then we try our best to always do so. So in order for us to avoid dealing with negative numbers or too many negative numbers, we have to be careful to subtract the smaller values from the larger values. And so in order to do that, we examine the equations again to see which one have more large values and which one has the smaller values. And so we take the smaller one and subtract it from the larger one. Now, by looking at it, I can say that equation 2 has smaller values, and so we're going to subtract equation 2 from equation 1. And so we write equation 1 minus equation 2. I hope we are all paying attention. All right, so just like the first case, just as in the first example, we're going to be, well, in the first example, we added the terms for the respective terms from the equation. But now we're going to be subtracting. So if you notice, I have one bracket minus another bracket, which means that we're going to be subtracting one term from an equation from its like term in the other equation. So of course, we're taking x from equation 1 and we're subtracting x from equation 2. So it should read x minus x. So it's x from equation 1 minus x from equation 2. We have to be careful to write the values in equation 1 first. Why? Because we're working it as equation 1 minus equation 2. So we put values or variables or terms from equation 1 first. So we should have 2y from equation 1 minus y from equation 2. And of course, we can't leave out our values. All right. That should be 2 minus 3. There's an error there. So please, if you're writing, make the correction. It should be 2 minus 3 because 2 is from equation 1 and 3 is from equation 2. All right, so it should read x minus x plus 2y minus y equals 2 minus 3. Now we simplify it. Of course, x minus x is equal to 0. 2y minus y is equal to y. And 2 minus 3 would give us negative 1. Please remember to make the correction. It should be 2 minus 3. Since we're subtracting equation 2 from equation 1, so it should read 2 from equation 1 minus 3 from equation 2. Now let us simplify. Zero is taking up space, so we can just go ahead and solve for y, and that is equal to negative 1. Now that we know the value of y, we can go ahead and solve for x. How do we solve for x? Now we simply substitute the value of y into equation. Well, we can substitute it, as I said before, into any of the other equation, but I am careful to decide on an equation that will make the entire process as simple as possible. So we always aim to simplify in the field of mathematics. So since equation 2 is it the simplest form, it's basically in a simpler form than equation 1. Now I'm going to choose equation 2 to substitute my value. So equation 2 is written x plus y equals 3. Now we already solved that y is equal to negative 1, so it's basically x plus negative 1, and that is equal to 3. So we now have a single equation in one single variable, so we can go ahead and solve for x. Now, when we have one equation, we just need one. When we have one variable to solve, we simply need one equation. Remember, when we're solving equations, if there's one variable, then we only need one equation. If there's two variables, we need two equations. 3 variables, 3 equations. 5 variables, 5 equations. So basically, that's how the system works. So we always want to aim to reduce it to one variable, one equation. And we have done so successfully. So we can go ahead and simplify. X plus negative 1 is basically simplified as x minus 1 equals 3. Now, since we're adding negative 1 on the left-hand side, we subtract negative 1 on the right. Or, in other words, since we're subtracting 1 on the left-hand side, we add 1 on the right. And so x would be equal to 3 plus 1. And we don't need a calculator to determine that 3 plus 1 is equal to 4. And hence, x is equal to 4. So, now we have it. The solutions for the system of equation are x equals 4, y equals 1. I want to give you some time for this to assimilate in your mind so that we can understand how simple it is to solve simultaneous equations using the method of elimination. So we basically analyze the equations to see if there are additive inverses present in the equations. And if there are additive inverses, we go ahead and add the equations. Of course, that is why we're looking for additive inverses, because we want to add. If there are no additive inverses, we can also look to see if there are like terms. If there are like terms, then we can subtract one from the other in order that at the end of all of that, we end up with one variable eliminated and we have an equation, one single equation with the other variable, one single variable, so we can go ahead and solve for that variable. Now, once we determine the value of that variable, then we go ahead now to substitute that value into any of the other equations of your choice, whichever you think would be easy for you in order to derive the solution of the other variable. And so that's basically what method of elimination is. Now there's another situation I want us to look at here. Now, I did say that we must analyze the equations to look for two things. 1, if they have additive inverses, or 2, if they are like terms. Now please, let's look at this example. Are there any additive inverses? Well, there is a negative and there is a positive, but the values are not the same. We see a negative 2, but we don't see a positive 2. And so there are no additive inverses there. Are there any like terms? No like terms. Are we in trouble? So what do we do in this case? Now, since I have told you before that we have to look for additive inverses or like terms, and now we are faced with a situation where we do not see any of these things, do not worry yourself. Now, we can manipulate these equations in order for us to attain any of the two. So whether we want to have additive inverses or we want to have like terms, we can simply modify one or both equations to attain an additive inverse or like terms. So we can either multiply equation 1 by 3. If we do that, when we multiply equation 1 by 3, we have to multiply all the terms in that equation by 3. So we do not interfere with the general meaning of the equation. When we do that now, we get 3 times x, that would give us 3x. 3 times negative 2y would give us negative 6y. And of course, the 11, 3 times 11 will give us 33. So when we do that, we have now an equation that has like term to equation 2. And those like terms are 3x. So both equations, we can identify 3x in both equations. Now, remember, if there are like terms, we go ahead and subtract one from the other. Now, I do not like to deal with negative numbers. Being a mathematician, I admit, it's my confession, we don't like negative numbers. Some parents or some students may ask, so sir, why not always kill with negative numbers? Well, they are in our reality and we have to deal with them. However, remember that if you don't have to, then we work in a way to avoid dealing with negative numbers. And so, in this case, I think I would try to attain additive inverses, so I can just simply go ahead and add the equations. And so, I'm going to multiply equation 2 by 2. When I do that, 3x times 2 will give us 6x, and 2y times 2 will give us 2y. And of course, our constant value, 12, multiplying that by 2 will give us 24. So note how I made my subtitle 2 times and then my circumscribed number 2. So that would simply read 2 times equation 2. Simply meaning I'm multiplying equation 2 by 2. Please note also that all the terms in equation 2 are multiplied by 2. Now, let us examine it. Or before we go, we have to be careful. Now we have another equation. So we have to label this equation, and I'm going to call it equation 3. There's already an equation 1 and an equation 2. So this one is going to be called equation 3. So what I'm going to do now, since the equation 2 was modified to equation 3, I'm going to compare equation 3 with equation 1. Now, my aim was to attain additive inverses so I can add them, because adding is is the easier thing to do. I am sure that you all can agree that it's easier to add than to subtract. And so that is why I deliberately went ahead to multiply by 2 so I can attain additive inverses. Now, if we look at it, equation 1 and equation 3, they are additive inverses. Those are negative 2y in equation 1 and positive 2y in equation 3. If we add those, we're going to get 0 and pretty much eliminate those variables. So let's go and add the equations. Notice how I write my circumscribed numbers, as I said before. So that would read equation 1 plus equation 2. Sorry, equation 3. So we're adding equation 1 to equation 3 because there are additive inverses involved. Now remember how we add our equations? We add all the like terms together. So we're going to add x from equation 1 to 6x from equation 3. Then we're going to add negative 2y from equation 1 to 2y from equation 3. And of course, let's not forget our constant. So we take 11 from equation 1 and add it to 24 from equation 3. Now I want us to pay attention to how these values were substituted. All the values, all the terms carry their sign with them. Of course, we know that if a term or a value is positive, then we don't have to write the positive sign. But note, when I'm substituting the negative 2 from equation 1, even though it read x minus 2y, we have to acknowledge that the 2y is of a negative nature, and so we have to substitute negative 2y. We have to be careful. I believe some students from time to time will try with substitute, but they tend to ignore that there's a negative sign in front of that value, and so they only carry over 2y in this case. They may tend to carry over 2y or substitute 2y and leaving the negative sign behind. We have to remember every number carries a sign, and so we must be vigilant. We must open our eyes. Remember, as mathematicians, we pay attention to details. So we have x plus 6x, x from equation 1 plus 6x from equation 3 plus negative 2y from equation 1 plus 2y from equation 3, and that is equal to 11 from equation 1 plus 24 from equation 3. Let us simplify this system, this equation. Now, x plus 6x gives us 7x, and by virtue of additive inverses, 2y and negative 2y cancel to give 0. And of course, we cannot forget our constant. 11 plus 24, and that should give us 35. Let's tidy it up a bit. We don't need that 0, it's taking up space. And so we write it as 7x equals 35. I hope we are following along. Now, at this stage or this step, solving for x should be very easy if we know our 5 times or 7 times. If a number is multiplied by 7 and it's equal to 35, what is x? So we basically know at this point want to solve for x. Since we're multiplying x on the left-hand side of the equation, we divide on the right, leaving x as our subject. And so when we compute 35 divided by 7, that should give us 5. And therefore, x is equal to 5. All right, so now that we know the value of x, we can't forget our y. Because when we're solving those equations, we have to find the values of all the unknown variables. So let's go ahead and solve for y. Now I'm going to substitute my value of x, which is 5, into equation 2. Now remember, we can use any of the other equations to substitute, but I'm just trying to see if I can find an equation that would make the work easier for me. And because equation 2 has y by itself, there is nothing multiplying it, it's going to be easy to solve for y in that case. The other two equations have a number multiplying y, and so it's going to take a lot more work to determine the value of y. And so I'm going to go with equation 2. Now equation 2 is stated as 3x plus y equals 12. My value of x was 5, and so I substitute the value of 5 where x was. So I have 3 times 5 rather than 3x plus y equals 12. So now we have an equation, one equation in one variable. And so we can go ahead and solve for y. Of course, 3 times 5 is 15. So when we simplify, it gives us 15 plus y equals to 12. And of course, since we're adding 15 to y on the left-hand side of the equation, we do the opposite on the right-hand side, which is to subtract. And so we write y equals to 12 minus 15. And I don't think we need our calculators to determine that 12 minus 15 will give us negative 3. So now we have solved for x and we have solved for y. So we can write our general solutions. X equals to 5 and y equals to negative 3. And that's all there is to it. My students would say that, sir, there is nothing to it. It's very easy. So what have we done here? The method of elimination. Let's recap this method a little bit. So we said that when we're using the method of elimination, we analyze the equations and we want to decide if we're going to add the equations or we're going to subtract one equation from the other. So in order for us to add the equation, we have to identify additive inverses. So we look at the two equations to see if they're additive inverses. If they're additive inverses, then I'm speaking too fast. If they are additive inverses, then we go ahead and add the equations. However, if there are no additive inverses, then we have to look to see if there are like terms. If there are like terms, then we subtract one equation from the other in a way to avoid doing more work than necessary. All right, so we try to decide which equation has the larger terms, and so we subtract the other equation from that. In other words, we're subtracting the smaller from the larger in the case of identifying like terms. Now, if we cannot identify like terms nor additive inverses, then we can simply modify any one or both equations by multiplying or even dividing by a particular common number to attain our additive inverses or our like terms before we can go ahead and add the equations or subtract one equation from another. So that is the method of elimination for us. Now I did say we're going to be looking at two methods. So that's elimination. Let's go to the method of substitution. All right. So the method of substitution simply involves expressing one variable in terms of the other. What does that even mean? Expressing one variable in terms of the other. All right, let's take this equation. X plus y equals 3. It's my favorite equation. You will see it everywhere I go. X plus y equal to 3. So how do I express one variable in terms of the other variable? Now there are two variables, x and y. So we're either going to express y in terms of x, or we're going to express x in terms of y. Now if we're going to express x in terms of y, what we simply do is to make x the subject of the formula, or subject of the equation. And so all the other terms are transposed to the right-hand side of the equation. So in this case, we're saying that x is equal to 3 minus y. In other words, x is being represented by the variable y. And so we say that 3 minus y is an expression of x. Why? Because that is what x is equal to. 3 minus y. So if we're going to express x in terms of y, we simply ensure that we have x as a subject and y transposed to the other side of the equation. What about expressing y in terms of x? If we're going to express y in terms of x, then we simply make y the subject of the formula and transpose x to the other side of the equation. And so we have y equals to 3 minus x. So we can therefore say that 3 minus x is an expression of y. Yes, simply because y is equal to 3 minus x. So now that we know how to express one variable in terms of the other, now we can go ahead and try our method of substitution. Now, once we have derived our expression, which is the expression in terms of the other variable, then we can now substitute this expression into the untouched equation. What do I mean by untouched equation? You'll see. First example. Now, I'm using the same set of equations that I used for our method of elimination. Now, that means we should get the same solutions that we got for the method of elimination. It shouldn't change the solutions. Now, x plus y equals 3, x minus y equals 1. Same equations that we used before. Now, we're going to express x in terms of y. In so doing, we write x is equal to 3 minus y. So therefore, we can acknowledge that 3 minus y is the expression of x. That's the expression that we derived from the equation 3 minus y. And so, of course, remembering that we derived this expression from equation 1. Right? Identifying that x plus y is equal to 3, then therefore, x is going to be equal to 3 minus y. We could derive it from the other equation, which is equation 2, which might be easier for us since transposing negative y to the right-hand side of the equation is going to give us a positive y. We all would like to work with positive numbers. But this is not going to be so hard. So let's go ahead and work with 3 minus y. So we're going to now substitute that expression, 3 minus y, into equation 2. Now remember when I said we're going to substitute the derived expression into the untouched equation. In this case, my untouched equation is equation 2. Why? Because the expression that I derived was from equation 1. If I had derived my expression from equation 2, then my untouched equation would be equation 1. So since my untouched equation in this case is equation 2, I'm going to substitute into that equation. So wherever I see x, instead of writing x, I write 3 minus y. So in equation 2, we had x minus y equals 1. So instead of writing x, we say 3 minus y in place of our x minus y equals 1. Now once we have that together, then we can simply go ahead and simplify the equation. So 3 minus y is pretty much 3 minus 2y because we're adding negative y 2 times. And of course, that is equal to 1. Now we have an equation, one single equation, one single variable. Now you might want to think that we have eliminated x, but we really didn't. We just simply write an expression that was given for x, which was 3 minus y. Hence, the method of substitution. So let us solve this. Now we can solve for y. Since 3 minus 2y is equal to 1, then of course we transpose the 3 over to the right-hand side, and we have negative 2y equals to 1 minus 3. Please bear in mind that 2y is negative, and so we cannot ignore that negative sign. Since negative 2y is equal to 1 minus 3, of course 1 minus 3 will give us negative 2. Now if negative 2y is equal to negative 2. Since we're multiplying by negative 2, we go ahead and divide. Of course, we could tell, some of us maybe could tell right away that if negative 2y is equal to negative 2, then y must be equal to 1. So that's the case there, because negative 2 divided by negative 2 would give us 1. So therefore, y is equal to negative 1. Now remember, in all the cases, we have to find, well, in both cases, method of elimination or substitution, we have to find one variable first before we can go ahead and find the value of the other variable. So now we know the value of y, let's determine the value of x. Now, I'm going to use the equation that I derived from equation 1, which says x is equal to 3 minus y. I did that deliberately because it is already stated in terms of x, and x is the value that I want to find. So, x equals 3 minus y. Now, we remember that we just determined the value of y, and that is 1. And so, therefore, x must be equal to 3 minus the value of y, which is 1. Our calculators don't need to be on for us to determine that 3 minus 1 is equal to 2. So therefore, x is equal to 2. Now we have solved for both variables, x and y, and so we can write our general solution. X is equal to 2, y is equal to 1. Very much consistent, because that is what we have determined for the method of elimination. This very same system of equation gave us x to be equal to 2 and y to be equal to 1. If you don't believe me, of course, at the end you can go back to the video and rewind to show that those were the values that we determined. Let's try another example. So we have here x plus 2y equals to 2 and x plus y is equal to 3. Now, this time I'm going to express y in terms of x. So I take equation 2. So I say from equation 2, y is equal to 3 minus x. Because equation 2 was stated as x plus y equals 3. And so we transpose x to the other side of the equation. So we can say that 3 minus x is given as an expression of y. So we're going to substitute 3 minus x into our untouched equation, which would be equation 1 in this case. So when we do that, we have now x plus 2 times whatever y is equal to. We put it in bracket, or expression of y, which is 3 minus x, and that is equal to 2. So we have x plus 2 times, in bracket, 3 minus y, and that is equal to x. Now we can go ahead and simplify. X plus 2 times 3, we use our distributive law here. So we're multiplying a bracket by 2, so we have to distribute 2 right throughout the bracket. So 2 multiplies 3, and that gives us 6. But 2 also multiplies negative x. Remember, we have to remember our negative signs. And that would give us negative 2x. And of course, that is equal to 2. Now we can tidy this up a little bit by adding our like terms. We identify x and negative 2x, those are like terms, so we can add them. And of course, x minus negative 2x would give us negative x. And of course, plus 6 equals 2. Since we're adding 6 on the left-hand side, we can bring that over to the other side of the equation to give negative x equals 2 minus 6. And we can compute that further to give us negative x, and that would be equal to negative 4, since 2 minus 6 would give us negative 4. And of course, if negative x is equal to negative 4, then x is equal to 4. Now that we've found the value of x, let us find the value of y. Notice that I deliberately use the equation that I determined my expression from. Now, I want to find the value of y. So I use the equation that states y as the subject of the formula. Now, since we have determined the value of x to be 4, then it shouldn't be a problem to substitute to get y equals to 3 minus 4. Our calculators need not to be on. 3 minus 4 is equal to negative 1, and so x is equal to, that should be y equals negative 1. So if you're paying attention, you should realize that there's an error there again. That should say y equals negative 1, since we're solving for y. And so your general solution should give x equals 4 and y equals negative 1. So a method of solution simply involves expressing one variable in terms of the other variable, and that expression that we derived, we substitute it into the other equation to solve for that particular variable that we end up expressing. We're going to end up having one variable and one equation. Once we solve for that variable, then we can now go ahead and to substitute again to determine the value of the other variable. So pretty much that's it for our lesson. Now I want us to try these in the rest of the time that we have. Now if you can, just use the time now to write down these equations. I want you to attempt solving these systems of equations using both methods of elimination and substitution. Alright, so just for recap, the method of elimination simply involves identifying additive inverses or like terms in order for us to decide whether we're going to add or subtract. Now, the purpose of adding or subtracting is to simply systematically getting rid of one variable so that we are left with the other variable in one equation. Now we can go ahead and solve for that variable and then substitute to determine the value of the other variable. The method of substitution, on the other hand, simply involves expressing one variable in terms of the other. Using that expression now to substitute into the other equation to determine that variable. And once we determine the value of that variable, then we can go ahead and solve for the other variable. In both cases, we have to solve for one variable first before we can solve for the other. Alright, so everything here is done systematically. Of course, that is what mathematics is all about, being systematic. Alright, so please do attempt these questions. I can give you, well, of course, my email address is there for us to, of course, send me your work so I can look at them. Now, I need to see those work coming in so I can identify those misconceptions, if there are any misconceptions, and make the corrections. I will be happy to see those email address. My contact information, my email address is on the slide, and I will be happy to see those emails coming in so I can respond. And of course,
show the middle company. Look in this.
All right, so please attempt those questions, and you can take a picture. My email address, as I said before, is on the slide. All right, it's not there. It's not there. Let me add it. All right, let us pray. So that was the end of my lesson, Simultaneous Equation. I hope we enjoyed it, and I hope we have learned something. Please send those emails so I can see, where we're going and what I can do so we can basically communicate. Now let us pray. Father God, we thank you for the time that you have afforded us to have this class. We thank you also for this platform so that persons can learn from home. As we are about to continue with the rest of the day, and of course, as the students attempt the exercises that were given to them, we ask that you grant us wisdom, grant us understanding. Be with us. And thanks again. In Jesus' name, amen. So that was our EJC online mathematics class. Thanks again for joining us. I'll see you next time.